Hello and welcome to this Raspberry Pi video. As you can see, I've got a barcode scanner connected to this Raspberry Pi and I've got a sheet of barcodes here. So I'm going to scan a couple of these barcodes using the scanner. As you can see, that information displayed up on the screen. Let me do a few more. So you can see the barcode is quite successful at scanning codes in and presenting into a Raspberry Pi screen. Now I always love it when I can use a Raspberry Pi to solve a real-time problem. Let me show you what I mean. So here I am in my place of work. This is the IT suite in a small primary school in a village somewhere in England. And this is the problem I've got. We have 10 classes and we have 16 iPads. Now the problem is the iPads are booked out continuously and I never really know whereabouts they are. So I tried to devise this paper booking system where the teacher is supposed to write in their name and then the code number of the iPad that they're booking out. But as you can see on this list here, now there's only 2 or 3 entries, but I know the iPads have been used every day this week. So if you know anything about teachers, you know they're extremely busy people and they don't really always have time to start writing and recording things like booking out an iPad. So it got me thinking there must be an easier way of doing this. Now I run the Electronics Computer Club and we use an awful lot of Raspberry Pis to teach the kids coding. So we use them for traffic light simulation, building robot cars, building line following robots, that type of thing. So I was thinking maybe I could use a Raspberry Pi to solve this problem. So the idea I've got in mind is to get a barcode, one for each teacher, maybe put it in the back of their ID card, or maybe I'll have a folder here with all of their barcodes. And then on each of the iPads I'll put a barcode as well, on the back here somewhere. And the process will be that the teacher will scan her ID, or his ID, then scan all the iPads and that will display information on a monitor, and I at least then can see who's booked the iPad out, the time and the date. So if I have to go hunting for them, at least I know whereabouts they will be in the school. So that's my plan. Let me go back to the office and I'll show you how I'm going to tackle it and go through the code that I've written, which is in Python. Okay, I'm now back in my office. Now when I start a project, I like to do or carry out a bit of a feasibility study to find out the scope of work and what I'm going to need in terms of equipment and how much it's going to cost and the complexity of the project, that sort of thing. So I normally start off with a list of parts. Now I've created a list of parts of what I need for this project, but one of my goals is to try and make it as cost effective as possible, because I do work for a school and I'm trying to keep the costs down, because if you work in a school, especially in the UK, you know at the moment where most schools are strapped for cash. So I'm trying to keep this down, to keep the cost down to a bare minimum if possible. Now luckily I have quite a few of the components already in the school. So the Raspberry Pi, I have numerous Raspberry Pis, because as I said before, we have a Electronics and Computer Club which I run, and we've got quite a few Raspberry Pis, so no problem with the Raspberry Pi or the power unit to go with it. Now I'm not going to use a keyboard or a mouse. I want the project to be, the only interface to be is the barcode and the monitor, the only 2 add-ons I'm going to use with the Raspberry Pi. So no keyboard and no mouse. Now the monitor, I've got quite a few monitors sitting around the school, so it makes no sense for me to buy a new monitor because I've got one that works perfectly well. The only problem I've got is that these monitors don't take a HDMI connection. They've only got VGA, but no problem. I use this little converter here, so a VGA comes out of the monitor into this little box here, and this HDMI plugs straight into the Raspberry Pi. Now I've used these numerous times around the school. They work really well, and they're really quite cheap as well. Around about probably £8-9, maybe £10 now. I don't know. Yeah, but not very expensive. The barcode scanner I'm going to cover off in a few minutes, because there are a few little issues when you're connecting a barcode scanner to Raspberry Pi. Nothing serious, but just something to be aware of, so I'll come on to that in a minute. The only other unknown for me was the barcodes. Where am I going to get barcodes from? Well, as it turns out, Amazon sell barcodes, and they sell them in these little rolls of 1,000 barcodes for say £21. Now, for 1,000 barcodes, £21 I think is a reasonable price, but I don't need anywhere near that number. I'm probably only talking about maybe a dozen barcodes. So for me, it didn't make financial sense to buy 1,000 codes when I'm going to use a fraction of that number. So I had a look around the internet and I found this fantastic website called barcode.tech-it.com. I'll put a link in the description below. But what this site allows you to do is create your own barcodes. Now, there are numerous barcodes outside here, but I found the best one to use with the Raspberry Pi and the scanner that I had was Code 39 Full ASCII. Now, that allows you to use not only numerals but also text as well. So what you can do is you can create you can see this is the barcode of this code here, but you can create your own. So I just delete that and type test-001 and do a refresh. You see it created the barcode for me there. Now what you can do, if you click on this button here, you can create numerous barcodes. 003. Now I did find that if you put in more than 5, and when you download it, it downloads it to a zip file, and inside a zip file are a number of GIFs, one GIF for every single barcode. But if I did more than 5, the 6th and the 7th barcodes were corrupt, so I could only use the first 5. So I think it might be something the website is trying to stop you from just downloading hundreds of barcodes in one go. Now, there's nothing stopped me to do 5 and then download them, do another 5, download them, do another 5, and that seems to work quite well. So for barcodes, this is really a good site to use. Now let me go on to the actual barcode reader, because there are a few little issues that I think you probably just need to be aware of. Okay, here you can see the Raspberry Pi is not connected to a monitor. It's connected to my laptop via a VNC connection, remote Wi-Fi connection, which normally works very well. But when I try to use the barcode scanner, look what happens. It's barcode scanners recognizing the code but not displaying anything on the screen, which surprised me really, because if I was to hit the keyboard and just hit some keys, they're appearing on the screen. Now the barcode scanner is supposed to just emulate the keyboard presses. So I was really surprised to find that when I used the scanner it didn't work. It disillusioned me a little bit, because I was thinking, a fantastic idea I've got of using this to solve my iPad booking in process, and now I can't use it. But I had a little think about it and I decided to, rather than use a VNC remote connection, to actually physically connect a monitor into the Raspberry Pi, and I repeated the test, and this is what happened. Okay, same test as before, but this time I have the monitor physically connected to the Raspberry Pi. Same barcode scanner, same book. This is the screen. So let me start to scan the book again. Now look at the screen. So it works when you have a screen physically connected to the Raspberry Pi, but it does not work if you want to do it over a remote connection. Now for me that's not a problem. I was always going to use a physical monitor, so works fine for me. But if you've got a project and you're planning on using a remote connection, you might have to rethink the idea. Okay, I'm going to go through the Python coding now, but before I do, I just want to cover off this algorithm. I always like to write an algorithm before I start a major coding project. I just think it helps me structure my thoughts, makes it easier to debug, that sort of thing. So starting at the top here, ask the user for their barcode. So basically ask the teacher to scan their barcode. Match barcode with user and start a timer. I'll come on to the timer in a few seconds. Then ask the teacher to scan the iPad barcode, match the barcode with the iPad, and display the teacher's name, date and time on the screen. Now this section here is, I need some sort of mechanism that the program will know when the teacher has finished scanning the iPads, because it could be more than just one, it could be several. So I need a end code. So what I decided to do is to put a I'll create a barcode that I'm going to stick on top of the monitor. So once the teacher has finished scanning all the iPads, they scan the barcode at the top of the monitor, and that will tell the program that they finished scanning, and will take them through this loop here, cancel the timer, and take them back to the default position, which is just asking the user for their barcode. That's the default position. Now inevitably a teacher will forget to enter the encode. So what I've done is I started a timer here, and after 90 seconds, if the teacher has scanned all their iPads and left the room and forgot to enter the encode, this part here, this branch here, will automatically log the teacher out and take it back to the default code, default position. So that's the algorithm that I'm going to be using. So let me go across now and look at the code, and I'll go through it in a bit more detail. Right, here I am with my Python program. I'll go through it in a bit more detail for you. When I first decided to set up this project, I wasn't quite sure what graphical user interface to use. In the end, I decided to use TKInter because I think it's the best application for a text-based program such as I'm using. I did think about using Pygame, but Pygame is very difficult to get text onto the screen, and it's not really designed for that sort of application anyway. So yep, TKInter was the way I went. So here I'm importing all the various libraries that I'm going to need, including some date and time libraries. Here I'm creating an instance of TKInter. Now I know most people tend to use root, but I always find root is a bit ambiguous. Window makes more sense to me, so I decided to use window as my instance of TKInter. Now I just jump to the bottom of the page for a second, and I'll show you how to configure the TKInter window. So from here to here are the parameters that we're going to need to set up the window. So if I launch the window, launch the program, let's minimize that for a second. So the first parameter is the geometry, 800 by 600 plus 0 plus 0. So 800 is the width, 600 is the depth. The 0 plus 0 is how you position it on the screen. Now you notice that when I launched it, it actually appeared right up here. That is 0, 0, as appears here. If you don't put them parameters in, when you launch it, sometimes it might start here, it might start there, it might start over here, it might start down there. If you want to be precise about where you want it to start, you have to put those parameters in there. Now the reason I've chosen 0, 0 not in the middle here is because once the program is sitting on the Raspberry Pi, I want this window, or this window will fill the whole of the monitor screen. So it will be perfect, it will fill every inch of the screen just perfectly. So I wanted it to launch so it appears right at the top left hand corner and to fill the whole screen. That's the reason why I'm using 0, 0 there. Now the next two parameters, frame 1 and frame 2, define how you split the screen up. So here, frame 1, that's frame 1 from there to there, from there to there, and from there to there. That is frame 1. Frame 2 is from here to here, right to the very bottom, and across to here. That is frame 2. The next parameter, I'm creating an instance of tree view. Tree view, this is tree view here. This bit that looks a bit like a spreadsheet. That's tree view. And down here I've created a function called tree view user interface, and that's the first program call in the loop. So if I now scroll up, let me just minimize that for a second, and scroll up to my tree view user interface function, I'll go through it in a bit more detail. So the first line, I'm setting up a number of global variables, ID 1 to ID 16, so they're going to associate each one of these, each with an iPad. The second line, I'm just giving the window a title, iPad booking system. From here down to here, these lines of code are responsible for setting up the TV window. So basically setting up this part of the window here. So this line here actually sets up the first column, which is the iPad column here. And you see it's got here anchor W. W means west. So basically what I said is I want the iPad name to be not in the middle, not on the far right, but on the far left. that's slightly in a bit. So I've declared it to be west, but I've actually padded it out with a few extra spaces just so that it lines up with these iPad labels here. Then I've got a number of columns. These are the column variables: booked out, date out, and time out. They associate with these three columns here. So that's booked out, that's date out, and that's time out. I know they've got different labels, but these are just variables. These names here are just variables. So for the variable booked out on this line here, it has a width of 200. So basically what that means is that column is 200 pixels wide. Date out is also 200 pixels wide, but this time the anchor is centered, so that's actually the date label is actually in the middle of the column. And likewise with timeout, that's also 200 pixels wide and centered in the middle. Okay. Then booked out, the variable booked out is now given a label called booked out by. So that's the text that appears in the top of the column. And the same for date out, which is now date, and the same for timeout, which is time. This last row, where to position T view on the frame. Do you remember on the screen? Do you remember there was two frames, frame 0 and frame 1? Frame 0 was row 0, column 0. Frame 1 is row 1, column 0. So basically, that's telling you where to put the tree view. The next 4 line of codes are just variables that I'm going to be using in the table of the tree view window. I've nulled them out because the information that I want to display first off is nothing. This just blank screen. Eventually they will be populated by a teacher's name, the date that they booked the iPad out, and the time. But for now, I'm just going to set them as null. Now moving down to the table itself, so you can see each ID1, ID2, ID3, ID4, each of those are iPads, and each of the IDs has their own set of parameters. So if I look at ID1 or iPad 1, it has an iPad name, so iPad number 1. It has the teacher, the variable name, which is going to be the teacher's name, DT, which is the date, and HR, which is the hour, and it has a tag of odd row. And the one below it is identical except for the tag which has even row. Now if you look at these two top lines here, basically it's a tag configured for each of the two rows. So an odd row will have a white background and a font size of 10. An even row will have a light blue background with a font size of 10. So basically odd row, even row, odd row, even row, odd row, even row. I just think it's going to make it look easier to display the text on the screen. The last line in this function is ask for barcode, which is the next function down. Now this really isn't doing anything more than just asking the user or the teacher to scan their barcode. If there had been any previous text from a previous user, these two lines here just blank any text that's on the screen beforehand. So nothing really interesting there. The only piece of code that's worth looking at here is this bind key function. What it's going to do, that's going to look at all the keys that the barcode scanner, or not the keys but the characters that barcode scanner scans into the system, and it's going to present them to the next function, which is called get teacher barcode, which is this function here. So what this function does is to read in the events generated by the barcode scanner character by character, and if it appears in this string here, it will add it to the variable code. Let me show you what I mean. If I open up the program, let's move that over a second, and watch this area here. Now I'm going to pretend I haven't got the scanner with me, so pretend I'm scanning it in, but I'm actually going to hit on the keyboard 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, and you can see that the variable code is built up character by character. So the first event in the barcode scanner is red, and that's a 1. So the variable code is assigned the character 1. Next time round is assigned the character 2. So the code now becomes 1, 2. The next time round is assigned 3. So the code variable now is 1, 2, 3, and so on and so on. So it becomes to 1, 2, 3, 4, 5. Minimize that for a second. These two next bits of lines of code really just print information on the screen, and basically what I've just shown you. You don't really need them, they're only there for diagnostic purposes. This piece of code here is looking for a carriage return. So I've got my barcode scanner set up that when it at the last character, it then inserts a carriage return, and this is what this event is looking for here. So if it captures a carriage return, it then assigns the variable code to the variable teacher, and then goes off and looks at the staff dictionary with the variable of code. So it'll look at the staff dictionary and look for 1, 2, 3, 4, 5. So if I go up to the staff dictionary, which is very minimal at the moment, you can see that it says 1, 2, 3, 4, 5, and it's assigned to Mrs. Scott, the teacher, Mrs. Scott. So if I go back to the screen and I now press carriage return, Mrs. Scott is recognised because it's looks at this dictionary 1, 2, 3, 4, 5, and the equivalent to that is Mrs. Scott. So that's basically what this piece of code here is doing. The next two lines basically nulls the variable code ready for the next scan, and this last line is get teacher name. So the teacher now name we now know is Mrs. Scott. It then passes it through to this variable here, and all this piece of code here does, all this function here does, is just display the teacher's name on the screen. So it recognizes it prints recognize on the screen and the teacher's name. This piece of code here which says after equals window.after, that's a timer. I set a timer up that at the end of the teacher scanning all the iPads, they're supposed to put in an end code which is 00. Inevitably they will forget that at some stage. So after 15 seconds, I've got it 15 seconds just set up for test purposes, but in reality that will be 90 seconds, 90. But after 15 seconds it will automatically log the teacher out and then go to ask for barcode function. So that's really what this piece of line of code here does. The next one is to ask to scan the iPads. Now to ask to scan the iPads is this function here, and really that's just placing information on the screen, asking the user to scan the iPads. And the last piece of code there calls this function, which is get iPad code, and this is identical to the one I showed you before with the teacher, except it's just checking for the iPad. So the dictionary you will look at will not be the teacher dictionary but the iPad dictionary. Everything else is identical. Now this next piece of code here, I feel I could have written it much better than I have at the moment, but the thing is it works, and it works really well. It's just not elegant, and when I get time I will rewrite it and make it into a class, but for now it works well, and I'm going to stick with it. So basically what this does is I've got some global variables here, device and statuses. I'll come on to them in a few minutes. These two lines here define the current date and the current hour. Now these if statements are looking for a character 1, which is iPad 1, character 2, which is iPad 2, character 3, which is iPad 3, and so on, and that information comes from the dictionary, the iPad dictionary. So if I scan in TSG iPad 01, then 1 is returned from the dictionary, and it's that 1 that is being looked for in this if statement. So if device is equal to 1, that means it's iPad number 1, and its status is in, that means it's actually in a cupboard, it's not been booked out. Then I immediately change the status to out, because that means that someone's going to book it out. And then I go to the team viewer identity number 1, and I change the value, which at the moment will be just blank, to the teacher's name. In this case that'd be Mrs. Scott, the date and the time that she booked it out. If the status is out, that means it's already booked out and the teacher's now booking it back in. I change the status to in, and in the team viewer I then ID 1, I change the values to null. So that means there would have been the teacher's name, Mrs. Scott, date and time, and they now are nulled. And that's the same for device 2, device 3, device 4, right down to device 16. As I say, it's an ugly piece of code, I know, and I can imagine really serious Python programmers out there screaming at the screen saying that this is a ugly way of doing things and not very efficient. I understand that, but for now I'm going to leave it as it is. These last two bits of line of code, once the teacher has scanned all their iPads, there's a end barcode attached to the top of the monitor, or there will be attached to the top of the monitor. When they scan that in, that is the signal for the program to say that the teacher's is finished scanning the iPads, and to basically default back to ask for barcode. What it will do, it will cancel the after timer, which you saw earlier on. If if the teacher has not scanned the end code, that means there's another iPad to be scanned, and it will go back round the loop. Now, inevitably, the teacher will probably forget to type in the end scan, and that's where the timing function comes into it. And basically that's it. We're now back to the geometry of setting up the window, which is what I covered earlier on. Okay, I think that's it for the Python side of the programming. I will put this on GitHub, so if you want to download it, play around with it, manipulate it, do whatever you want, I have no problem with that. Okay, so the next thing is to show you it all working in the school itself. So the scanner's been in working now for a couple of days. Teachers seem quite happy with it. About to move it to another location because some of the younger children thought the barcode scanner itself was a toy. So I've moved it to a corner of the ICT suite where the younger children don't get to go to. The only other thing I need to mention is this little box here. The reason I've got this is that the scanner doesn't like to be left on for long periods of time. So I was reading through the instructions and they advise you not to keep it on all the time. The problem being, with it being in a school, it could be on up to 8 hours a day. So what I've done, I've created this little timing device here. So basically inside there's a little 555 timing circuit. I'll show you that in a few minutes. So you just press the button. It turns the scanner on for 2 minutes. That allows the teachers to scan their code, scan the iPads, and then after 2 minutes the timing circuit will just switch off and therefore switch off the barcode. So that seems to work quite well. Let me open up the box and I'll show you what it looks like inside. Okay, this is inside the timing box. So basically what I have here, this cable goes to the Raspberry Pi, the USB port of the Raspberry Pi, and this USB socket here is the actual barcode scanner itself. Now on the USB, the outer pins of the USB connections are power. So what I've done is I've actually broken the power to the positive side of the USB connection and fed it through to this relay here. And this relay is activated by the timer. So when the button is pressed on the box, the IC555 timer activates that relay for 2 minutes, which closes that connection and therefore turns on the barcode scanner. Simple as that. I'll put a circuit diagram up immediately after this video, and the coding, the Python coding and this circuit diagram will all be available on GitHub. Okay, thanks for watching. Bye for now. As a footnote to the video, I just thought I'd go through the timing circuit with you. So here we have the Raspberry Pi, and normally the barcode scanner will plug directly into this port here. But what I've done was I've used a USB cable that has a plug in that end and a socket in this end. That's important because that's where the barcode scanner is going to plug in. So what I've done was I put a piece of variable board in there and I've actually cut the cable in half and soldered these wires on it. Now I'm guessing really you could have probably just stripped away, or I could have stripped away the sleeve and intercepted the red power wire, but I decided I was going to use a variable board, so it's up to you if you ever want to do that. I've soldered the connections onto a variable board, and you can see here that there's a break in the variable board here, so the red wire is not connected straight through, so it's intercepted by these two wires here, which goes through this relay. So in its default state, there is no power going to the USB connector, therefore the barcode scanner is off. So when I've got this little 5.5 timing circuit here, what happens is when I press the button on the box, which is this switch here, it sends a low condition to the trigger pin. The trigger pin goes high through this resistor, which powers up this transistor. The transistor goes closed circuit, and I've now got a path from 5 volts through the relay, through the transistor down to ground, and that then activates this contact here. The contact closes and powers up the USB and the barcode scanner. and it powers out for 2 minutes, and the 2 minutes is determined by these two components here, this 1 mega ohm resistor and this 100 microfarad capacitor. Now if you want to go higher or lower, make a higher value or lower value in terms of time, then you just have to play around with these components here. So that's it. It's a very, very simple circuit. IC55 timers are really cheap to buy. They're pennies. I think I bought 100 for about £5. Yeah, so that's the circuit. So thanks for watching. See you again.